look at our introduction to proofs, we need to review some of the properties that we learned from algebra. And then we're going to talk about some of them that we talked about way earlier in the year, and now they're coming back to haunt us, so to speak. But the addition property simply says that if we're given A equals B, if we add some number to A, we can add the same number to B and keep that equation in balance, so to speak. And the thing is, we can use addition, we can add something to both sides. It works the same way with subtraction. If A equals B, then we can subtract some value from A. And if we subtract some value from A, we also have to subtract some value from B. And the process still works on the multiplication and the division. Multiplication. If A equals B, then if we multiply something times A, then we can multiply B by that same something. And division as well. One thing just to keep in mind is we can divide. So if A equals B, then A divided by C equals B divided by C. Off to the side it says C does not equal 0 because we're not allowed to divide by 0. Distributive property, another property that you're more than likely familiar with. And what that says is we can take what's outside the parentheses and we can multiply it by what's inside the parentheses. So we get AB plus AC. A times B plus A times C. And don't overlook the fact that within the distributive properties, sometimes we need to combine like terms. So if we have something that's the same, we can add them together or whatever needs to happen. And then finally, from our algebraic properties, the substitution property says if A equals B, then either A or B may be substituted for the other in the equation. And you're going to see this more as we go throughout the unit here in terms of the notes. But the way to think about this one is, what we're doing here is we're replacing something. So if A equals B, then we can replace B with A. But we're replacing it. And again, we'll see it more as we go throughout the unit than just the straight, here's the theory behind it. In terms of the most important ones, it's going to be the subtraction property and the substitution property. And we'll even see the substitution a little bit today. But those are properties from algebra that you may or may not remember. We have some properties from geometry as well. The first one is the reflexive property. And if you think of reflexive, sounds like reflection. If you look in the mirror, what you see is the reflection of yourself. So the reflexive property simply says that A equals A. And it seems redundant sometimes, but it's important sometimes as well. We actually do use the reflexive property more than we think we're going to. The symmetric property, I oftentimes talk about it more so in algebra than in geometry, but the symmetric property says if A equals B, then B equals A. And finally, the transitive property. Well, the transitive property, I think of transitive like transport. So transporting means you're going from one place to another. It's the same thing that's happening here. If A equals B and B equals C, what we're doing is we're transporting A across the B's and we're landing on the C's. That didn't show up very well, but what the transitive property says, if A equals B and B equals C, then A must also equal C. And that carries over here, so this is the properties of equalities. Then when we look to the right, what happens is we've got congruence. And the properties of congruence, what's changing here is that we need to say that A is congruent to A. Remember that symbol here, because we haven't used it for a while, is congruent. And the symmetric property, if A is congruent to B, then B is congruent to A. And again, the transitive property, we are transporting, if A is congruent to B and B is congruent to C, then A is congruent to C. Proof. A proof is a logical argument that shows that a statement's true. So that's what the definition of proof is. And most of what we do in geometry here is going to be a two-column proof. And what happens with a two-column proof is we have numbered statements and then what we do is we give a reason to back up that statement. A reason that shows an argument, and you want it in logical order. And most of the time for our reasons for proof, a lot of, especially today, what we do is we use definitions. Spelled that wrong. Got the N. Definition is going to be a valid reason for a proof. We also have something called a theorem, and we've seen a couple of them, but more so what we've done is we've used them, and we haven't really looked too closely at them. But if you look down below here, theorems are rules that are proven true. So something that somebody else has already proved. We also have postulates. And a postulate, again down below, is rules that are accepted true without proof. We don't have to prove a postulate, we just accept it. In general, it's one of those, it's so obvious that we don't have to do something extra with it. And then the other one is what we were just talking about, these properties of equality. When we write proofs, we always write the given first. And the thing is, even if you can't do the proof, at least you should be able to fill in three things. The statement that's given, and the reason, and then the next part, which is the last statement in the proof, is always what we are trying to prove. Again, even if you can do nothing else, you should be able to write down the given statement, the reason, and what we're trying to prove. And that can eliminate some of the blanks that we have to fill in, too. And as we flip over here, now let's get an idea of what we're working with here. Again, we're just doing bits and pieces with a couple proofs at the end. And Here's our examples. It says, draw a conclusion based on the diagram or given information. So here's what's given. M is the midpoint of XY. Now think about what midpoint means. Midpoint means that M is in the very middle of this segment. And once we realize that, and what we can say here in terms of our statement is we can say that XM is congruent to M1. This length here is congruent to that length there. And then we have to come up with a reason. Well, the reason here goes back to our vocabulary word, midpoint. And the definition, and oftentimes you can abbreviate, I'm going to try not to abbreviate, but definition of midpoint is the reason. And about 95% of the time, if you see a vocab word in the statement, then you can say definition of that vocab word. Doesn't work all the time, but it works on most of them. Letter B. Given that ray DB, too many words there, bisects angle ADC, that's given. And this one kind of goes along with this last one. We had midpoint in the last one. This time our word on here is bisects. We need to think about, well, what does bisect mean? And it means we're cutting that angle in half. So in other words, what's happening here is that this angle is going to become congruent to this angle. And that's the statement that we can make. We can say that angle ADB is congruent to angle BDC. And again, 95% of the time, if we have a vocab word as part of our, how do I want to say that, as part of the statement, then we can use definition of, I'm going to go angle bisection. And to get, today again, we're looking at parts here. We're just looking at just a tiny piece, and hopefully at the end we'll pull it together. Gonna skip the next one for a moment and jump down here to letter E. It says given angle 1 and angle 2 are supplementary. So once again, we see this word supplementary, which is a vocab word. And when we've got a vocab word here, we need to think, well, what is the definition so that we can make our statement. And supplementary, what it means is it means that if we take angle 1 and we add it to angle 2, we're going to end up with 180 degrees. That's what the definition of supplementary means. And again, supplementary, vocab word, most of the time we can use that for definition. And I'm going to abbreviate definition as DEF. Definition of supplementary. I will. I guess we're dealing with angles here. Definition of supplementary angles. So watch out for the words in our statements that help us come up with the reason. If we look at letter F, it says the measure of angle 1 is congruent to the measure of angle 2. The measure of angle 2 is congruent to the measure of angle 3. Well, what can our statement be? Again, this one is probably a new property for you. But again, measure of angle 1 is congruent to 2. Measure of angle 2 is congruent to angle 3. We can skip the middle part. We can transport 1 across the 2's. So we can say that the measure of angle 1 is congruent to the measure of angle 3. And on this one here, not a definition. We weren't given any vocab word in the beginning of the problem, but we were able to use one of our properties, transitive property. And I maybe should have saved that one for a little later here, and stuck with the ones that more so use the vocab words, because as we get to this next one here on letter G, it says BD is the median of triangle ABC. Well, again, median, another vocab word, so hopefully that's going to be helpful in a moment. But what can we say here, or what do you remember about median? Well, hopefully you remember that median means that this, in my disoriented board here, that's the midpoint. Can't write on there, but I'll try. That's the midpoint at letter D. It says BD is the midpoint. Once we recognize that median, which starts with M, and midpoint, which also starts with M, what we know then is that this length here is the same as that length there, because D is the midpoint. And that's going to allow us to fill in our statement then. Our statement being that AB is equal to DC. But we had a vocab word. We had that vocab word of median, but we can say definition. Again, I'm going to abbreviate definition as DEF of median. So again, looking for the vocab words is certainly going to be helpful as we work our way through this unit. As we flip our paper over here, and I'll come back to the one that I haven't done yet, but we flip our paper over on another G here. This time what we're given that line M is parallel to line N, and our statement, we're already given our statement, we don't have to come up with it. It says that angle 3 is congruent to angle 6. So if we take angle 3 here and angle 6 there, and we mark up our picture, when we look at this, what we want to know is, well, what kind of angles are angle 3 and angle 6? Which takes us back to our parallel lines, and we had something that we talked about way back in the early days of geometry, where we said that when we have two parallel lines, again, what we need to recognize is what kind of angles are angle 3 and angle 6, and hopefully you recognize that these are alternate interior angles. Two parallel lines cut by transversal. Angle 3 is in between the two parallel lines and on the left side. Angle 6 is in between the two parallel lines on the right side of the transversal being T. Letter H, again, given the picture and given the statement, so we just have to come up with a reason on this one. It says, given triangle ERV, the statement says segment RN is congruent to segment RN. This is something popularly used when we look at triangle proofs. But what we think here, probably when you see this for the first time, is, yeah, Rn definitely equals Rn. It's the same thing. Well, if we recognize that fact, what we say then is that property, which is, if I can write it correctly, the reflexive property. Again, think of the reflexive property as like the reflection. When you look in the mirror, you see yourself. So we go back to the letter C now. And what I said is that 95% of the time, when we have a definition, or we have a vocab word, we use definition. But there's a time when it's not going to work, and it's going to be on this one. And what it says is, it says angle 1 and angle 2 are vertical angles. And that's going to be helpful for us, at least for the statement part of it, because what we know about vertical angles is we know that angle 1 is congruent to angle 2. That's what we know about vertical angles. They have the same measure. But nowhere in the definition of vertical angles does it say that they're congruent. It says that they are equal. So there's a couple of reasons. I think the one that's going to be easiest for us is simply to say that vertical angles are congruent. We just make that statement, which comes from the fact that they're equals, so then we take them to the next level, which is congruent. So as we flip over here to the end, let's look at really what a full proof looks like. So here's an example of a two-column proof. Here, we're going to fill in some parts. And remember, some of the stuff should be freebies. Even if you do nothing else, you shouldn't leave this blank, because the first statement always is what we are given. So if we look up here, it says given. B is the midpoint of AC. That's what we're going to write. B is the midpoint of AC. And oftentimes it's a drag and drop on the test. And the thing is, the reason given. And no one should leave that blank. Even if you can do nothing else, you should be able to do that. There's one more part that we can always fill in, and that's going to be the last statement. We might not know the reason, but the last statement is what we're trying to prove. And this one says prove that AB plus CD equals BD. So now all we have left is we have 3 parts to fill in. And certainly with the word blank, do I think you could get 1 or 2 of those? I'm going to keep my fingers crossed. And we've got basically the entire month of April to review to get to that point. But let's look at our first statement here, number 2. Because remember, a proof is a numerical order here. We've got our given. So it says AB is congruent to BC. AB is congruent to BC. Well, why do we think that? And if we go back to what's given, B is the midpoint of AC. There's a vocab word in this. So what we can say is, if this is the definition of midpoint. And here's where sometimes the redundant part comes in. So we've got AB is congruent to BC, but we need to take that congruency out. So what we can also say is that AB equals BC, and that's the definition of congruence. And it seems redundant, but it's something that we really do need. Luckily, it's filled in for us. So what we know so far, let's see that AB equals BC. And now what it says is it says BC, let me highlight it, BC plus CD. Well, if we add those two together, what do we end up with? Well, I tried to put it in here in green. I'm close. But what happens is that added up to be BD. So originally what we know is that AB equals BC. So we know this length. And then we know the green length. The nice part here is we added. We added BC plus CD together to get BD. So what we did is we added. There's that segment addition, the addition postulate. So then the last part here is the AB plus the CD equals BD. What we're trying to prove, and let's see if we can come up with our answer here. Well, in this part, we have a CD that's the same from statement 4. We have the BD that's the same from statement 4. The only thing that changed from statement 4 to statement 5 is that we had BC. We had BC in this one, and then now we have AB in this last one. That's the only thing that changed. And because of that, what we can say is, instead of writing BC, we replaced it with AB, and that is the substitution property. Substitution property for our last step. One last proof here. Let's try to pull it all together. And it says fill in the 2-column proof below. This one says angle 1 and angle 2 are straight angles. And again, even if you could do nothing else, start with that. Angle 1 and angle 2 are straight angles. And the reason is given. Finish this part with the fact that we're trying to prove that angle 1 is congruent to angle 2. Again, even if you can do nothing else, everyone can do that much. So now we've got 3 blanks to fill in. Measure of angle 1 equals 180 degrees. Measure of angle 2 equals 180 degrees. Well, what's our reason? Again, straight angles goes back to a vocabulary word. This is definition of a straight angle. So now, what we can say here is that measure of angle 1 equals 180, measure of angle 2 equals 180. Because they both equal 180 degrees, we can say that the measure of angle 1 equals the measure of angle 2. And there was some discussion on this. I said that the reason was substitution. However, I can see how you might think that this is transitive property, and I would give you credit if you use the transitive property. Measure of angle 1 equals 180, measure of angle 2 equals 180. We can transport across the 180 degrees. So lastly, how did we go from the measure of angle 1 equals the measure of angle 2 to our final statement, which is that angle 1 is congruent to angle 2? Well, what we did is we just converted. It's the definition of congruence. If they're equal, then they're congruent. If they're congruent, then they're equal.